Heat flows from warm to cold objects. We call this heat transfer. Heat can be transferred through conduction, convection, and radiation. Conduction is heat transfer via direct contact, such as a pot on a stove. Convection heat transfer is the transfer of heat from one place to another through fluid motion, such as air and water. Thermal radiation travels by electromagnetic waves, such as how you feel the heat radiate off of a fire or feel the warmth of the sun on your face. If you want to experience heat transfer yourself, think about how it feels to hold a warm cup of hot cocoa on a cold day. As you hold the warm cup, the heat travels from the cup to your hands. What materials make the best thermal insulators and conductors of heat energy? This is thermal insulators and conductors. During the winter months, here in Northern California, it can get pretty cold. This is the coat I choose when I venture out in the snow-covered mountains. My puffy coat keeps me really warm. The material in the jacket provides a thick layer of insulation. This thermal insulation helps slow the heat transfer of my body heat. Heat flows from warm to cold objects. If the material in this jacket slows the release of my body heat, what materials will slow the release of thermal energy of a liquid? Today, you will conduct an experiment to decide whether a material is a better insulator or conductor of heat energy. Materials that are good conductors of thermal energy are called thermal conductors. Materials that are poor conductors of thermal energy are called thermal insulators. For this investigation, you will need a temperature sensor, a 100 milliliter graduated cylinder, plastic wrap, cold and warm water, and 3 cups of various materials. Today we will use a paper, plastic, and styrofoam cup. It may also be helpful to have a calculator handy for the analysis section of the investigation. Let's get started. First, you will want to record the type of cups that you're using in Table 1 and Table 2. Pause the video while you do this. Next, connect your temperature sensor to your device. I'm going to collect sensor data, make sure my temperature sensor is connected, and I'm going to choose the digits display under templates to show me temperature. We're going to start with cold water first. So I'm going to put 100 milliliters of water into each cup. Make sure I'm measuring properly. Leave it flat. There we go. Last one. Okay. All right, we want to measure the starting temperature of each cup. I'm going to start with the paper cup and put the temperature sensor in and click Start. But I want to give it a chance to stabilize before I record any data. So the temperature's going down. Starting to slow a little, so we're close. So the starting temperature of the paper cup is 8.8 degrees Celsius. Now let's move to the plastic cup. (8.5 degrees Celsius. The styrofoam cup. (7.8 degrees Celsius. Pause the video to record this data into Table 1. Now cover each of the cups with plastic wrap. Make sure it's nice and secure around there. I like to have the top to be flat and tight. All right, and my styrofoam cup. All right. You're going to wait for 10 minutes and then you're going to come back and record the ending temperature. So we'll come back in 10 minutes. Okay. So now we're going to record the ending temperature in Table 1. So let's start with our paper cup. Gonna have to let it stabilize. Almost there, it's starting to slow down. Okay, so the ending temperature of the paper cup is going to be I think 11.5 is safe to say there. Now let's check the ending temperature of the plastic cup. The ending temperature of the plastic cup is going to be 11.4. And then finally, let's check our styrofoam cup. That one's still dropping. So the temperature of the styrofoam cup is going to be 9.4 degrees Celsius. All right, so the last step in this is to calculate the change in temperature that occurred in each cup. Remember, change in temperature equals the ending temperature minus the starting temperature. You can pause the video to complete Table 1. Now let's repeat the same procedure with warm water. So I'm going to get these out of the way. Next round of cups. I have some warm water over here. So I want to put 100 milliliters of water into each cup. I should leave this down. Okay. Paper. A little bit more plastic, and lastly 100 milliliters of water into the styrofoam cup. Okay, now let's check the starting temperature of each of these. I'm going to start with the paper cup. Again, we want it to stabilize. It's climbing up pretty quick here. Still going. Okay, so let's call the starting temperature of the paper cup is going to be 41.6 degrees Celsius. The starting temperature of the plastic cup is 42.9 degrees Celsius. And you can see why we're doing this, because the temperatures are going to fluctuate a little. The starting temperature of the styrofoam cup is going to be 43.7 degrees Celsius. All right, so You want to make sure to record that data in Table 2 for your starting temperatures. And then I'm going to cover each cup again with the plastic wrap. Nice and tight. And you're going to wait another 10 minutes to come back and check the ending temperature. So we'll be back in 10 minutes. All right, so it's been 10 minutes and it's time to record the ending temperature of each of our cups. So let's start with the paper cup. Just waiting for it to stabilize, starting to slow down a little. Almost there. All right, so the ending temp for the paper cup is going to be 36.2 degrees Celsius. Next is our plastic cup. That is going to be 36.9 degrees Celsius. And then finally our styrofoam cup. Almost stabilized. The styrofoam cup is going to be 39.6 degrees Celsius. All right, so once you've recorded those in Table 2, the last step is to calculate the change in temperature that occurred in each cup. You may want to use the calculator for this step. Remember, change in temperature is ending temperature minus starting temperature. You can pause the video to complete Table 2. You can now take the data you collected to answer some questions related to thermal insulators and conductors. You should be able to explain how heat transfer helped you determine which materials would be better as an insulator or conductor of heat energy. Enjoy your investigation.